Chapter 4, Exercise 4.45, Part A. Between these two elements, how can we write out a reasonable chemical formula? Calcium is in the second column. Calcium would like to lose 2 electrons to form the electron configuration of argon. Te is element number 52. It's 2 electrons away from the electron configuration of xenon. So Te would like to gain 2 electrons. There's a balance here. Calcium gives away 2 electrons and Te gets 2 electrons. So the formula is simply CaTe. After calcium loses 2 electrons, it forms calcium 2+ cation. After Te gains 2 electrons, it forms Te2- Ni. Barium and chlorine. Barium is also in the second column. Barium would like to lose 2 electrons to form the electron configuration of xenon. Chlorine is only 1 electron less than argon. So chlorine would like to gain 1 electron. Since barium gives away 2 electrons, chlorine gets only 1 electron. We need 2 chlorine atoms to receive the 2 electrons from barium. The formula should be barium and then chlorine 2. When barium loses 2 electrons, we have barium 2+. When chlorine gets 1 electron, we have chlorine minus. Potassium and Se. Potassium is in the first column. That means potassium would like to lose 1 electron. Se is only 2 electrons away from krypton. So Se would like to get 2 electrons to form the electron configuration of krypton. How do we balance the number of electrons? Well, we need 2 potassium atoms, each giving away 1 electron to Se. Therefore, the formula should be K2 and then Se. You can see it's balanced. Each potassium bears a +1 charge, Se bears 2- charge, and now we have a neutral ionic compound. Part D. Aluminum would like to lose 3 electrons. Sulfur would like to gain 2 electrons. Apparently it's not balanced, but we can find the common factor between 3 and 2. That's only 1. And then we can have 3 times 2 divided by the common factor. We get 6. Well, somehow we need to have 6 electrons moving from aluminum to sulfur. How do we do that? We just need 2 aluminum atoms, because each aluminum can give 3 electrons. 2 aluminum, 6 electrons. And then sulfur. Each sulfur gets 2 electrons. Now we have 6 electrons moving from aluminum to sulfur. Now we have the formula here. If we replace sulfur with oxygen, we will also get a correct ionic formula for aluminum oxide. This is because both sulfur and oxygen prefer to get 2 electrons. Alright, you can look at this formula here. Each aluminum is 3 plus times 2, that's 6 plus. Each sulfur is 2 minus times 3, it's 6 minus. 6 plus from aluminum and 6 minus from sulfur cancel. So this structure is neutral.